Now let's talk about the t-test. The t-test is a test used to validate if two different data sets measuring the same variable have different means or not. So in my t-test, the null hypothesis is always mu1, which is the mean of data set 1, is equal to mu2. The alternative hypothesis, mu1 is not equal to mu2. Or I can write this as mu1 minus mu2 is equal to 0. And I can write this one, mu1 minus mu2 is not equal to 0. I use this null hypothesis and this alternative when I have to use two-tailed test. This is for two-tailed test because the alternative hypothesis says that the means are not equal, which means why it's a two-tailed test. It's a two-tailed test because mean 1 can be either less than mean 2 or greater. This what the alternative hypothesis means. Now, if I want to perform a one-tailed test, it would be this way. I say that the null hypothesis mu1 is equal to mu2, and the alternative hypothesis would be that mu1 is less than mu2. This is an example of a one-tailed test because the alternative hypothesis claims that mu1 is less than mu2. So it's a one-tailed test. Let's see now an example from the IB question bank. Mrs. Kaloun measures the heights of students in her mathematics class. She is interested to see if the mean height of male students M1 is the same as the mean height of female students. Since I'm testing means of two data sets measuring the same variable, then I'll be performing a t-test. The information is recorded in the table. At 10% significance level, a t-test was used to compare the means of two groups. The data is assumed to be normally distributed and the standard deviations are equal between the two groups. Now, for part AI, we have to state the null hypothesis. Part AI, H node says mu1 is equal to mu2. Or we can write it as mu1 minus mu2 is equal to 0. Part I, state the alternative hypothesis. The alternative hypothesis, which is as HA, is simply mu1 is not equal to mu2, or I can write it as mu1 minus mu2 is not equal to 0. For part B, we have to calculate the p-value for this test, because also for the t-test, in order to reject or accept a null hypothesis, we have to use the p-value. The p-value also have the same rule as the chi-squared goodness of fit test. The p-value, I will write it in here in blue again. We have to compare the p-value with the significance level. If the p-value is less than the significance level, then we reject each node. If the p-value is greater than the significance level, then we do not reject each node. Let's continue our example. We need to calculate the p-value for this test. We have to go to our graphical display calculator. We go to statistics. First, we have to delete all the lists. Delete all. Delete all. And delete all. I have to fill in the male heights in list 1, so it's 150. 148, 143, 152, 151, 149, and 147. In list 2, I have to fill in the female heights. 148, I have 152, 154, 147, 146, 153, 152 with the last value 150. And now we go to test and we press on the t-test. The t-test, I have 2 samples. Now, the data, we have it in list. This is the alternative hypothesis that mu1 is not equal to mu2, which means I have a two-tailed test. The first data is in list 1 and the second data is filled in list 2. So now, we go to execute, having our p-value. We only look on the p-value. Our p-value is 0.297. So the p-value is equal to 0.297. Let's continue for part C. State, giving a reason whether Ms. Kaloun should accept the null hypothesis. Now, the p-value, I have it, 0.297, and the significance level is 10%. The significance level is 10%, which means this is 0.1. So, for part C now, I have the p-value 0.297 0.297 is greater than the significance level, which is equal to 0.1. So, because the p-value is greater than the significance level, we do not reject. Do not reject H node, which means we accept H node. Do not reject is the same as accept the null hypothesis. I hope it's clear. I hope you understand clearly how we use the t-test. Also, I use the p-value, and by this we solved an example from the IB question bank.